All right, so I'll probably just call on a few of you. If you'd like to volunteer, you can with your definition. Some of them are very good out there, but some of you, I will caution, it is normally not customary to use a word in its definition. So similar polygons, normally you're not going to use the word similar in the definition. You kind of have to define what similar means, right? Obviously, they have to be polygons. We know what that means, but we're talking about what makes them similar. Would anybody like to share theirs? Again, there were a lot of very good answers out there. Yes?
Shapes that have congruent angles and the sides have the same ratios.
All right, very good. It says shapes that have congruent angles and the sides have the same ratios. Very good. Another way of saying the sides have the same ratios, the sides are proportional. Very good. If you take the vocabulary from 7.1, which is obviously why we did the vocabulary in 7.1. Okay. Again, saying something like polygons that are similar, I don't know. That really doesn't tell me a whole lot. Unless I exactly know what that means, that's not a very good definition. That's like calling the definition of a circle. It doesn't help, right? In fact, that's one of the hardest definitions you're going to run into this year, to actually come up with that definition. So maybe start thinking about that one. It's a very simple object, but the definition is quite complex, really. So pretty good. Anybody else want to share something they put in there? I think that's pretty well focused because that's about what I have. So polygons with corresponding angles congruent, or if you say angles congruent, I just put corresponding because they kind of have to be in the same spot. And the measures of corresponding sides, again, the same matching up sides, are proportional, which is basically exactly what was said. There. Well, I went right back in there. Oh well, I'll figure out the new software soon enough. I don't like that that's right in the way, but it's still there. There. I would say the key is to actually do it in that order as well. Make sure first that they're both the same type of polygon, because don't try and match up a quadrilateral and a hexagon. They're not going to be similar. They have to be the same polygon. So quadrilateral versus quadrilateral, or pentagon versus pentagon. And you have to make sure that the corresponding angles are congruent. Make sure you do all of that before you go and find out if the sides are proportional. And please keep in mind, the angles are congruent, not proportional. Okay, that's where a lot of people go wrong, and they have a lot of difficulty with that when they try and solve problems. So if we take a look here, the very first thing we should try and figure out is, are they at least the same type of polygon? Yeah, they're both triangles, so we at least have a shot here. Because you would be surprised, you think that'd be obvious, but there has been years in the past where I give a trapezoid versus a hexagon, and people try and tell me they're similar. Okay. And then it does want us to justify your answer. On these, your justification will be your work, showing what you did. So the next thing, according to what I said, is we should check the angles. Well, here we have two angles on this one on the right. We have 26 and 14, which basically means how much 40's been used up. So how much is left over? 140. Well, I've got 140 and 14, so I think mathematically this better be 26, right? And so are the corresponding angles congruent? Yeah, I got 14, 14, I got 140, 140, and 26, 26. So we're good. They are, the right ones are matching up. So far, we're 2 for 3, right? We got the same polygon. We're checking the angles. Now we got to check to make sure the sides are proportional. And what you do is you basically just pick whichever triangle you want to start with, or whichever polygon you want to start with. So let's start with the one on the left. I see a 4.5 over here. So let's start setting this up. 4.5, I would like to compare it to another number. That's where the ratio comes in. And which number am I probably going to compare it to in the other triangle? Well, whichever one corresponds to that. And which number over there corresponds? Yeah, the 2. Very good. Now, here's the key. I hope that it's equal to all the other ratios. But you have to keep whatever pattern you started. It doesn't matter if your pattern's the same as mine, but you have to make sure whatever pattern you start, you follow. I basically took a side from the left one and put it over a side from the right one, correct? And so if I'm going to do this, I can go then do 7.65 over what? Which one corresponds to where 7.65 is? 3.4, very good. Now here's what some people do when they get in trouble. They'll go and do something like this. And then pretty much every single time they tell me they do not have similar polygons. What did I do wrong? Well, I didn't follow the pattern. I said left over the right one, right? That's what I did for the first one. This one is left, 7.65, over the right, which is 3.5, but then all of a sudden I did right over left. Okay, you got to keep the pattern. That's not correct. And so 11.7 over 5.2. Now, right now I have an equal in there, but do we really know yet? Is it very possible that one of them is different? And that's all it takes. One of these being different, it's no good. If they're all the same, we're fine. A couple ways you can go about this. Well, this little symbol right here really means to do what? It really means divide, right? So could you go and find all three of these decimals? Yeah, and if all three decimals are the same, you're good, right? And another way you could do it is kind of what I taught you, is find out that diagonal and compare it to that diagonal. They better be the same, right? And then I could compare that diagonal to that diagonal, and it better be the same. How come I don't have to compare the first to the last? What I've done's enough. What property is that that allows me to only do those? Yes? Transitive property. Remember that one? I think it was these three individuals right here that one day, wasn't it? Height or IQ or something, I don't know. Yes, it was height. Is that what it was? That's the transitive property in use right there. Now, either way you do it, you should come up with the same answer, though. If you do it one way, you shouldn't say yes, and the other way, no. All right? Either they are or they're not. And what did you find out about these two triangles? Are they similar or no? Yes, they are. And here's the symbol for similar, just a little squiggle. And where have you seen that little squiggle before? Other than Spanish, and it kind of looks like the tilde, right? Yeah, congruent, right? And that's exactly what we do when we do congruent. We say they are similar, and on top of being similar, they are also equal. And doesn't that make sense? Similar means it's kind of the same shape, proportional, and then equals means that the proportions are actually the same, like perfect, 1 to 1. Okay, and so that's where congruent actually comes from. Is a combination of equal and similar. So are there any questions on testing A here, how we did it? All right. Well, why don't you go ahead and test 1B on your own. I'll come around and see how you're doing. As I went around, it was looking very good. It looked like a lot of you were getting there. Remember, the first one is, do you even have the same polygon? We have a quadrilateral and quadrilateral. I don't know any more than that. But I did something tricky this time. I did kind of twist them, turn them around on you a little bit. So you had to make sure you had corresponding stuff. And so next thing you should always take a look at is the angles. Well, what do we think about angles? We've got 50 degrees and 50, 1 mark versus 1 mark. So the angles are good. Then we have to check, remember, angles have to be congruent, not proportional. That's key. And now we have to just check the sides. And you just have to come up with some pattern. Maybe this time I'll do right over left, just to show you it doesn't matter. If yours is a little different than mine, you should still come up with the same answer. It shouldn't matter. So let's say 6 over, well, which one matches up with 6? Corresponding would be 4, right? And then if I go to 10.5, it would match up with the 7. Again, we're looking for corresponding. I'm going to run out of room here. Maybe then I go to the 15, right? And that would be over what, 10? And the last one, whoops, there we go. The last one is what, 12 over 8. As you can see, if I flip that last one every time, I'm always going to say no, right? And so I think a lot of these are pretty easy to simplify. This first one's really just basically 1.5, right? 3 over 2. This one, 15 over 10, is also 3 over 2. This is also 3 over 2. How about that 10.5 over 7? That's kind of a weird one, huh? Is that actually 3 over 2? Yeah, it's actually 1.5, isn't it? And so this might be one just to go get those decimals, or the ones you don't know, go get them. But these actually are all the same ratio. Or for you, it might be 2/3 if you did it the other way, right? But, and in the end, similar. Okay? That's what I mean. Even if you had 2/3 or 3/2, it doesn't matter. You should still have the correct answer in the end. Okay? So are there any questions on the first example? A and B. They are good. You had to know this was going to happen. Please don't make the assumption that these are trapezoids, because we don't know the parallel and all that stuff. But we are told something very important. We are told that the two of them are not congruent, similar. Remember, that's similar, that's congruent. Big difference. Okay? So similar means that the sides might be proportional, but the angles are going to be good, and so we look at A, the angles are good. And so what we have to do is basically find, X and Y. Well, the problem is do we know what the ratio has to be? We know that the sides have to be proportional because we're told it's similar. So we have to somewhere find that ratio. And so you go to sides, I know this 2 corresponds to that 4. So I know the ratio is 2 to 4. And now you just got to kind of figure out, well, which one do I want to solve for first, x or y? It's funny that we normally choose x first, just by default. And so let's say we wanted to choose x. Well, x corresponds with the 8. And so which one should I put on top, the x or the 8, based on the way I set up the ratio? X, because it comes in that same order. So x, because it was with the 2, right? X over 8. Once again, is it okay to write 1/2 instead of 2 over 4 before I start the problem? Sure, it's the same ratio. It doesn't matter. But maybe you don't want to do that, and that's fine. And I know some of you are going to do it a little different, but I'm going to do it the way I taught. 16 equals 4x, right? That diagonal equals the other one. And then you're going to turn around and divide. So x is apparently 4. Now let's face it, this one's a pretty easy ratio, right? I'm basically doubling to get to the one to the right. So you probably knew this had to be 4, right? And in fact, most of you probably already know why. Okay? But let me show you how that would work if you had to use the proportion. You would go back to the one you know, which is 2 over 4, or again, 1/2 if you wish. And then you know it's a 5 and a y. There it is, stuck right there. And if you follow the ratio, it'd be 5 over y. So what is that, 20 equals 2y divided by 2. Y is, as most of you already knew, 10. And so are there any questions on that one? Well, let's face it, you knew algebra had to find its way in here somewhere. What's different about the next example? Other than the fact it's a pentagon this time instead of a quadrilateral. Anything different? Yeah. You know, we're talking about an angle this time, and I will tell you right now, this is the most commonly done wrong by a lot of people. Not necessarily x or y, but most commonly done wrong. Once again, if you're going to do one of these problems, you got to make sure that it is similar, and that's what that says. It says it's similar. So the sides have to be proportional. So we got to find that ratio. Right there are the only two we know, 4 over 16. Okay? And then we have to start using, well, what else do we know? Now we could go and try and solve x first, but the problem is there's nothing down there, right? So how are you supposed to solve for x first when you've got nothing to work with? Okay. Well, that's not helpful, is it? Or do we know what it has to be? What does it have to be? Yes. I could. I don't have to solve for y first, but I could. But what has to be down here based on the markings? Yeah. Yeah, 5, see? Congruent, right? So just because it's not there doesn't mean we don't know it. All right, so let's put a 5 down there. Because we know from up here and from there it has to be 5. And so if I'm going to go 4 over 16, and then I better set this one up as 5 over x, right? Now this is one of those cases where I would actually rewrite the problem and say, forget that, I'm not using that all those big numbers, right? Let's just rewrite it. Simplify, and if you can take that one fraction and simplify it, it's the same ratio, right? It makes it a lot easier. So that's 20 equals x. Look how easy that one made it. I'm done already. I didn't even do anything. Okay. Any questions on how I got x? Now y, you actually have, quite interestingly, you have a couple ways you could go get y. You could set up a proportion again. Is there maybe a slightly quicker way now? Yeah. Yeah, this is 20 now, right? And look at the markings. That one also has to be 20 when I'm done. So what does y have to be? It has to be 18, right? Now, is there anything wrong with setting up the proportion again? No. But sometimes, you know, think a little bit, right? And now what I'm going to show you is the most common mistake for people doing that angle. So obviously, if this is a mistake, don't write it down unless you really want to, I guess. All right. So here's what they do. All right, the ratio is 4 to 16, and so I got z plus 45 to 100. They get going with that proportion, and they do it every time. They don't stop to think, hey, the ratio is 4 to 16 here. Let's do it. Let's use it. They forget that angles are not proportional. Angles have to be congruent if you're talking similar. So do not set up that ratio for angles. Can you set it up for sides? Yes. But please do not do that for angles, because you can imagine the chance of actually getting it right if you do it that way. Pretty slim, right? But what we do know is that this angle A on this one and the angle F on that one are corresponding. We know that from up there or just looking at the picture. And so we basically know Z plus 45 has to equal 100. And all you have to do is subtract 45. And so Z is, what, 55? Okay. And so please watch out for that. I'm telling you that it's a mistake. Please don't make that one. Okay. So similar is not too bad. Once you know proportional and ratios, it's really not that bad. So recap, check to see if they're at least the same polygon. If they're not, don't even worry about it. Then check to make sure the angles are actually congruent, the corresponding angles, and then make sure the corresponding sides are proportional. Everybody good?